The Story of Everything, Chapter 3, the first 100 billionth of a trillionth of a trillionth of a second, the cosmic inflation epoch, 10 to the negative 38 to 10 to the negative 35 seconds. Sophia said, "It is now 10 to the negative 38 seconds after the Big Bang. The universe is still many times smaller than a proton, but it has grown enormously since the Planck epoch, and so it has cooled down from 10 to the 32 degrees to a brisk 10 to the 28 degrees, which is 10,000 times cooler than it was during the Planck epoch, but still a billion trillion times hotter than the center of the sun. What has happened is that the universe has expanded and cooled down enough by this point that this exact moment saw the next major phase transition, which is when the strong nuclear force broke off from the electroweak force." I asked, "Which is the electromagnetic force and weak force combined, right?" "Yes. According to the version of the Big Bang story currently most popular among astrophysicists, the energy released by this phase transition triggered a brief period of exponential expansion of the universe, in which the universe doubled in size every 10 to the negative 38 seconds. During this time, the universe expanded far, far faster than the speed of light, because all the energy of the universe was dumped into a field closely coupled with space itself, the inflaton field, which caused the whole universe to suddenly balloon outward. This is the era we call cosmic inflation. In just 100 billionth of a trillionth of a trillionth of a second, the observable universe, which is the universe you can see in the 21st century, went from being much smaller than a proton to the size of a human, while the rest of the universe, beyond what we can observe, grew to at least 100 billion light years wide, depending on how big the unobservable universe is." "How can the universe grow faster than light?" I asked. "I thought nothing could go faster than the speed of light." "No particle of energy or matter can travel faster than light, but space itself has no speed limit. Space can expand as fast as it wants. The particles themselves don't move apart from each other faster than light on their own, but rather the space in between them grows. Thus, during the superfast expansion of inflation, each particle experiences itself as just moving along like normal, while it sees all the other particles around it seem to fly away. And the farther away a particle or observer looks, the faster the other particles seem to be moving away, because there's more space in between that's growing, until the farthest ones vanish completely because they are moving away faster than the speed of light. And this is true for each and every particle in the universe during expansion." "Do the particles expand too?" "No, but their wavelengths get longer. It's just the space that expands. That's still true in the 21st century too. The reason objects don't expand is gravity and the other forces. Gravity holds together large objects like planets and galaxies, and atomic and molecular forces hold small objects like plants and animals together. So bodies don't get bigger with the expansion." Regarding the particles seeming to move apart from each other during inflation, if it helps, imagine a group of rubber duckies floating side by side in a creek. Now imagine that the creek becomes wider and wider until it's an enormously wide river. The ducks will move away from each other and eventually lose sight of each other. But the ducks aren't themselves traveling away from each other. Instead, it's the river's growing width that is separating them from each other. Or consider a balloon with little dots painted on it. As the balloon is filled with air, it gets bigger and bigger, and so the dots move farther and farther apart, but the dots aren't really moving. It's the rubber surface of the balloon that's getting bigger and creating more space between the dots. Okay, I think I understand. It's the space itself that is stretching faster than the speed of light, not the particles, which can't go faster than light. That's correct. Now, we're going to go slowly through the inflationary epoch and pay close attention to what happens, because this is part one of the most important science lesson ever. I replied, I'm ready to see the grand design. True to her word, the universe around us started getting bigger. The zoo of particles started thinning out as they began drifting away from each other. I saw the wavelengths of particles getting longer, and I felt the intense heat begin to cool down. Soon the universe was so big that I could no longer sense where its edge was like before when we were scrunched into a tiny dot, although Sophia still had me so small that I could see particles with my magic vision. So the universe wasn't big yet. We were only just entering the cosmic inflation epoch. As the universe continued growing, the particle zoo turned into a wasteland with just a few stragglers. Pretty soon, there were no particles at all. The universe was completely black again, and for the first time, it felt empty and cold. But it was then that I noticed something I hadn't seen before when the universe had been crammed full of bright particles. It seemed like I was seeing ghostly pairs of gray particles emerge out of nothing, travel just a little way apart from each other, and then come back together and vanish again. Now that my eyes could focus on these faint objects, I began to see them everywhere, like pairs of ghost fish jumping out of the same spot of black water, meeting each other in the air and vanishing. Sophia, can you pause the universe for a second? You mean for less than a trillionth of a trillionth of a trillionth of a second? Yes. Sure. What am I seeing here? What are these pairs of little particles blinking in and out of existence? She replied, now that all the GUT particles have inflated away, you're seeing for the first time that empty space is never truly empty. It's time to learn a big phrase, vacuum fluctuations, also called quantum fluctuations. Vacuum means empty space, space with seemingly no matter or energy in it. Fluctuation means a kind of back and forth change, specifically the activity you're seeing of particles coming into existence and annihilating each other. Seemingly empty fields fluctuate constantly, producing these temporary pairs of particles and antiparticles. Together they cancel out, so as soon as they're born, they almost instantly meet each other again and vanish. Quantum mechanics states that it is impossible to know both the position and the momentum of a particle at the same time. This is called the Heisenberg uncertainty principle, and it has profound and strange implications. One of those implications is that even empty space must be in a constant state of change. This is because quantum uncertainty applies to energy as well. So the energy of empty space, the vacuum, cannot remain zero. It must fluctuate to remain quantumly uncertain, even if that means borrowing energy from the universe that isn't there. As long as the energy debt is paid back by a certain time, a very short time, this violation of the conservation of energy is allowed. This means that an empty quantum field is never really empty. Instead, it ripples like water under a gentle breeze. Look closer. You'll see that instead of a pair of particles, it's more like a wave that suddenly appears in the field, just like a wave might appear on top of water, with a little bump here and a little dip right next to it. Then the bump flows into the dip, and the water is flat again. You saw real particles flying around and crashing into each other with a burst of intense radiation. Now you're seeing these ghostly particles appear and disappear without a trace. These are called virtual particles, and they are the star of the show in the inflationary epoch. Every field has these fluctuations, but right now you're seeing the quantum fluctuations of one field in particular. a mysterious field called the inflaton field. All the energy you saw in the GUT field in the grand unification epoch got pushed into the inflaton field because of the phase transition that separated the strong nuclear force from the electroweak force. And the inflaton field is so closely coupled to space-time that all that energy being dumped into it is driving the outrageous expansion of the universe you're witnessing now. Meanwhile, as the universe expands during inflation, random quantum fluctuations in the inflaton field are producing particles called inflatons. More specifically now, virtual inflatons. I asked, why are they called virtual? Because they don't really exist, at least not permanently. They're just a very temporary divergence from minimum energy. Kind of like a zero splitting into a +1 and a -1, and just as quickly being added to each other to return to zero. It was zero all along, but it just decided to fake us out by pretending to be a +1 and a -1 because of quantum uncertainty, and because the energy of empty space isn't allowed to settle at a certain minimum. That's the borrowing and quickly paying back I mentioned. Nature at the tiny realm where quantum mechanics applies likes to keep us guessing. The virtual inflaton and its anti-inflaton change the value of the inflaton field the way that a +1 and a -1 might temporarily change, say, 100,000 into 100,001 on the positive side and 99,999 on the negative side, before quickly combining back to 100,000. This change in the value of the field will become very important when inflation ends. I asked, why are these virtual inflatons part of the most important science lesson ever? She said, well, let me show you what happens next. Sophia unpaused the universe, and I continued to see the pairs of virtual inflatons emerge and annihilate. But as the expansion of the universe continued to accelerate, the arcs that these particles, or rather bumps and dips, traced out, from popping out from a single point to annihilating at a single point, kept getting wider and wider. Pretty soon, space was expanding so fast that these virtual inflatons were being ripped apart from each other. They became too distant to annihilate each other, and they stopped looking ghostly. They were now real bumps and dips in the fabric of space. Each time an inflaton flashed into real existence, it caused the space around it to ripple up or down, depending on whether it was a positive or negative fluctuation. It's hard to describe what Sophia was showing me. After all, no matter how magical your eyes, you can't really see fundamental particle waves in an invisible field, let alone virtual particle waves. So Sophia had to improvise some visuals for the sake of the lesson. It was like seeing raindrop impacts appear out of nowhere in a vast pool of calm water, except that instead of a hoop radiating outward from the point at which the raindrop hit the water, the drop, the inflaton in this case, permanently caused either a slight mound, the positive inflaton, or a slight depression, the negative inflaton. And those grew ever wider as the expansion of the universe continued to enlarge everything. Or you could say it was like the positive inflatons made the space around them thicker and the negative ones made the space thinner. As these lumps in space got bigger and bigger, new raindrops would impact and cause new ripples that grew. As each raindrop kept impacting, space would continue expanding the ripples so that there were lots of new little ripples within the huge old ripples, and so on until the whole universe became filled with big ripples and tiny ripples and everything in between. It was like seeing big hills and big valleys and little hills in the big valleys and little dips in the big hills, and so on down to the tiniest bits of space being thick or thin. And all of this was happening in 3D. Eventually, when the universe became enormous and my normal-sized body returned, the expansion slowed down, and as I would soon find out, the ripples within ripples would be frozen in place permanently. Speaking of frozen, why is it freezing cold, Sophia? I thought the Big Bang was supposed to be bright and hot, not dark and cold. She replied, it's because the universe is now stretched out and diluted and empty, and all the energy has been going into the expansion of space. So the temperature is now practically 0 Kelvin, which is as cold can get. It's about negative 459 degrees Fahrenheit right now, or negative 273 Celsius. But that's about to change. The moment she finished those words, spots of light quickly formed all around me until from the top of my head to my ankles, I was engulfed in a dense ball of fire.